Okay, we're going to look at number 8 in section 3.5. It's a little bit involved and drawn out a little bit. We're going to calculate the first, second, and third derivatives for this function right here, x to the fifth times e to the 2x. So immediately when I talk about taking the derivative of this, you should immediately think I'm going to have to use the product rule, right? Because I have x to the fifth, that's one function of x, times e to the 2x power, which is another function of x. So the product rule, if you remember how that works, I take, so the first derivative would be take the derivative of x to the fifth times e to the 2x plus x to the fifth times the derivative of e to the 2x, right? That's what little prime marks mean. Okay, so that's the product rule. Basically, take the derivative of one function times the other plus the derivative of the other function times the first. Okay, x to the fifth, that's easy. That's just a power rule. Bring the 5 down, subtract 1 from the exponent, I get 5x to the fourth. But what's the derivative of e to the 2x? Okay, first of all, it's not power rule. I don't bring the 2x down and subtract 1 from 2x. No, because in the power rule, the exponent has to be a constant. The base is x, or whatever the variable is, the exponent has to be a constant. Is the exponent a constant here? 2x? Is 2x a constant? No. So this is not power rule. So some of you might just say, oh, well, this is the exponential function rule, right? So you remember that the derivative with respect to x of e to the x is e to the x. And then you might say, well, the derivative of e to the 2x is just e to the 2x. Well, you'd be wrong. It's actually 2 times e to the 2x. You say, what? Where did that come from? Okay, well, a little bit later in section 3.7, we're going to be looking at the chain rule, and we'll show how to do this one quickly with the chain rule, but we don't need the chain rule here to do this one. If I want to find the derivative with respect to x of e to the 2x, that's the way we can write that with the Leibniz notation. Notice e to the 2x can simply be written as e to the x times e to the x, because remember, when I'm multiplying like bases, what do we do with these exponents? We add them. X plus x is 2x. And now what do I have? This is just a product rule again, right? I've got one function times another. Just turns out that both functions are the same. So I take the derivative of e to the x times e to the x plus e to the x times the derivative of e to the x. Which these are both the same, obviously, so it's just basically 2 times this, but what's the derivative of e to the x? E to the x in both cases. E to the x times e to the x, as we said, is e to the 2x because I add the exponents. This also is e to the 2x. So e to the 2x plus e to the 2x, I've got 2 e to the 2x. So that's why that's the case, okay? Later on, or if you know the chain rule already, then you can apply that a little bit quicker. Okay. So with that, I have 5x to the fourth e to the 2x. And then this 2 right here, I'll just bring out in front of the x to the fifth, e to the 2x, and write it that way. I usually put my numerical factors up front. Okay, so that's fine. If you're doing the test for me, you can write it that way, but you can indeed factor. This is the way I think Achieve wants it. They might accept this answer. In fact, if you're going to factor, you might as well factor out a x to the fourth as well. You know, if I were doing this problem, I don't know why Achieve wants this particular answer, but it might accept this one. I'm good with this right here. I mean, you could indeed actually factor this. As I said, you can factor out a x to the fourth e to the 2x, and you would be left with here just 5. And here you'd be left with 2x. I mean, you could factor it that way. I mean, this answer, this one in the red, this one, they're all fine for me, okay? Later on, as we get into chapter 4, we may be interested, when is this derivative equal to 0? And then factoring it like in this form could then be very helpful. Okay. So again, Achieve has some particular ways they want answers done, so make sure you check with that. If you have any troubles with that, certainly always let me know. Okay, so that's just the first derivative. Yeah, we got a lot more to do. We got to find the second and third derivative. So the derivative of this thing is the second derivative. I'm actually going to use this one here that before we factored anything out. So notice this is a product rule because it's 5x to the fourth times e to the 2x. So I take the derivative of 5x to the fourth times e to the 2x plus 5x to the fourth times the derivative of e to the 2x. So that's just the derivative, right, of this one. And then 2x to the fifth e to the 2x, I take the derivative of 2x to the fifth times e to the 2x plus 2x to the fifth times the derivative of e to the 2x. Again, product rule on that. So both of them require a product rule. Okay. Now, derivative of 5x to the fourth, power rule, bring the 4 down, 4 times 5, 20x, subtract 1 from fourth to the third power. Derivative of e to the 2x is 2e to the 2x. We talked about that up here, so that's the same. 2x to the fifth, bring the 5 down, 5 times 2 is 10, subtract 1, x to the fourth, 10x to the fourth. And again, e to the 2x is that. So clean this up, I get 20x cubed e to the 2x here. 5 times 2 is 10 x to the fourth e to the 2x. 10x to the fourth e to the 2x. Interesting, these two. And then 2 times 2 is 4 x to the fifth e to the 2x. These two can be combined because they are like terms. They have the same variable parts. 10 plus 10 is 20 x to the fourth e to the 2x. So there's that. And again, that answer is fine for me. If you factor out the e to the 2x, this is maybe what Achieve wants. It might take that as well. I hope it does, but either one is fine. You can also factor it. As I said, you can factor out an x cubed. In fact, you can factor out a 4x cubed, right? Because 4 comes out of these as well. So I'm not sure why Achieve wants it factored necessarily that way. Okay, but that's the second derivative. Now, third derivative, well, yeah, it's going to be a little complicated because this one requires product rule, right? 20x cubed times e to the 2x. This requires product rule, 20x to the fourth e to the 2x, and this requires product rule. Okay. So product rule here, take the derivative of 20x to the third power, which is bring the 3 down, 60x squared times e to the 2x, plus 20x cubed times the derivative of e to the 2x. Well, we know what the derivative of e to the 2x is, right? 2e to the 2x. So I get 2 times 20 is 40 x cubed e to the 2x. So this is a product rule for this one here. This one, same thing. Derivative of 20x to the fourth, bring the 4 down. I get 80x cubed e to the 2x. And then the derivative of e to the 2x is 2e to the 2x. So 2 times 20 is 40 x to the fourth e to the 2x. So there's the product rule on that one. This one, product rule again, derivative of 4x to the fifth, bring the 5 down, 20x to the fourth times e to the 2x, and then derivative of e to the 2x is 2e to the 2x, 2 times 4, 8x to the fifth e to the 2x. All right, so there's the derivative. I can combine like terms. We're adding these two terms together, gives me that. They're like terms. These two terms here together, add to that. And then we get our final result here, which again, we can factor out. Okay. Just put an asterisk on this one just real quick. The way I went through this is fine. You could have also found this derivative by taking the derivative of this in the box here, where you just use a product rule, take the derivative of this times e to the 2x, and then derivative of e to 2x times this, and then expand. I did that right here, right? If we have that 5x to the fourth plus 2x to the fifth, if I take the derivative of that times e to the 2x plus all that in parentheses times the derivative of 2x. So I could do it that way. And this derivative is pretty easy by just the sum rule, constant multiple rule, power rule. E to the 2x derivative is 2e to the 2x. And then I just have to do some distributing through of things. And after I've done all of that and combine like terms, you get the same result. So this may be a little bit easier in finding the derivative doing it this way as well. Okay, so again, just got to practice these things, be careful. Your algebra is real important in simplifying these expressions. If you're having trouble with that, as always, please contact me for help.